Hi students, today we are going to discuss the topic shortest distance between two straight lines. Shortest distance between two straight lines, there are two formula. First one, shortest distance between the parallel lines, and the second one, shortest distance between the skew line. First one, shortest distance between a parallel line. First one, parallel line. Parallel lines. What is a parallel lines? It is the board is a plane. Now draw a line. Draw a line. The line is r vector equal to a vector plus s of u vector. The line is r vector equal to a vector plus s of u vector. Given one point and one parallel. That is a straight line, equation of straight line. And draw another one line in a plane is in board. The line is r vector equal to b vector plus same s of u vector. U vector, s of u is the direction are same. The two lines are parallel. Two lines are parallel. That is a two lines are parallel. That is a parallel lines. The next one, the parallel lines coplanar. That is a coplanar is two lines are in the same plane. That is a coplanar. What is the distance between the two straight lines? The distance between the two straight lines, the shortest distance between two straight lines, the first one r vector equal to a vector plus s b vector. So right in u vector is b vector, r vector equal to a vector plus s b vector, and the second line r vector equal to c vector plus t of d vector. T of d vector. That is a equation of two lines. Now find the shortest distance between the two lines. That is a d equal to modulus of c vector minus a vector. C vector minus a vector. C vector minus a vector cross b vector. That is a two lines are parallel. Now write in a direction is same b vector. That is b vector. Two lines are parallel. Two lines are parallel. C vector minus a vector cross b vector by modulus of b vector. That is the shortest distance between the two straight lines. R vector equal to a vector plus s b vector, and the second line r vector equal to c vector plus t of b vector. That is the direction are same b vector are equal vector. Therefore the two lines are parallel. Therefore the distance d equal to modulus of c vector minus a vector cross b vector by modulus of b vector is a shortest distance between the parallel lines. Next one, skew lines. Next one, skew lines. What is the skew lines? Skew lines. Skew lines is draw a two line. The one of the line is that is r vector equal to a vector plus s b vector. This is one of the line. And another one line, draw another one line r vector equal to a vector plus t of d vector. T of d vector. Therefore, two lines are neither intersecting nor parallel. Neither intersecting nor parallel is called a skew lines. The two lines neither intersect nor parallel is called a skew lines. What is skew line? Neither intersect nor parallel is called a skew lines. The distance between the skew lines. The distance between the skew lines. The distance between the skew lines d equal to the distance between the skew lines d equal to modulus of c vector. That is the point is suppose to write in a c vector minus a vector, c C vector minus A vector dot B vector cross D vector. B vector cross D vector, that is a modulus, by modulus of B vector cross D vector is a shortest distance between skew lines. D equal to distance D equal to or delta area 1 modulus of C vector minus A vector dot B vector cross D vector by modulus of B cross D is a shortest distance between a skew lines. Now discuss exercise problem, exercise 6.5. Second one, show that the lines R vector equal to 6i vector plus j vector plus 2k vector plus s of I vector plus 2j vector minus 3k vector, and R vector equal to 3i vector plus 2j vector minus 2k vector plus t of 2i vector plus 4j vector minus 5k vector are skew lines, and hence find the shortest distance between them. Given two lines are skew lines, to show the result, given the two lines are skew lines, and next one we have to prove, find the shortest distance between them. Find the shortest distance between skew lines. First now write in here, equation of the line is R vector equal to 6i vector plus j vector plus 2k vector is, that is the point is A vector. Write in here, A vector equal to 6i vector plus j vector plus 2k vector, that is a point A, plus s of R vector equal to A vector plus s of B vector, that is the point is B vector, where B is the parallel of direction. It is a B vector equal I vector plus 2j vector minus 3k vector, and right in the second equation of the line is R vector equal to 3i plus 2j minus 2k, R vector equal to C vector plus t of D vector. Now right in the form is R vector equal to C vector plus t of D vector. Now right in the C vector is 3i vector plus 2j vector minus 2k vector, and D vector equal to, where D is the parallel, D vector equal to 2i vector plus 4j vector minus 5k vector, that is a D vector. So that the lines are skew lines. Already you know skew lines are neither intersecting nor parallel is called a skew lines. Already you know. It is a direction. R vector equal to A vector plus S of B vector. That is a direction is I vector plus 2j minus 3k. And the second line is this one, R vector equal to C vector plus T of, this is a parallel, that is a direction. Now I vector plus 2j vector minus 3k vector, and comparing the two directions, this one is 2i vector plus 4j vector minus 5k vector is not parallel. B vector and D vector is a, B vector is not a scalar multiple of D vector. So given the two lines are not parallel, therefore given the two lines are skew lines. Clearly B vector is not a scalar multiple of B vector is not a scalar multiple of D vector. So the lines are not parallel. So the lines are not parallel. Not parallel means given the two side lines are skew lines. Therefore the two lines are skew lines. First one, show that the lines are skew lines. So first number, verify given the two straight lines are skew lines. Next one, find the shortest distance between the skew lines. Next one, the distance between the skew lines. Distance between the skew lines. This distance between skew lines is D vector equal to modulus of C vector minus A vector dot B vector cross D vector by modulus of B vector cross D vector. That is a formula. The distance between skew lines is D vector equal to modulus of C vector minus A vector dot B vector cross D vector by modulus of B vector cross D vector. First now find C vector minus A vector. C vector minus A vector equal to C vector minus A vector. This C vector is 3i plus 2j minus 2k. A vector 6i plus j plus 2k vector. Now subtract the two vectors. 3 minus 6 minus 3i vector. Next one 2 minus 1. 2 minus 1 is 1j vector. Next one minus 2k minus 2 minus 4k vector. Minus 4k vector is C minus A. Next find B vector cross D vector. Next find B vector cross D vector. B vector cross D vector equal to B vector cross D vector means vector product of two vectors. Vector product of two vectors by using determinant form. Determinant of I vector, j vector, k vector, and the component of B is this one 1 2 minus 3 1 2 minus 3, and the component of D is 2 4 minus 5 2 4 minus 5. That's one. Now expanding the determinant. I vector into getting a minor matrix 2 into minus 5 minus 10. 2 into minus 5 minus 10. Formula is minus 4 into minus 3 minus 12. Formula minus half minus plus. 4 3s are 12. Next one, taking the element j vector, column and row are eliminating, getting the minor matrix 1 minus 3 2 5. 1 into minus 5 minus 5. Formula is minus 2 into minus 3 minus 6. Lady formula minus half minus plus. 2 3s are 6 plus 6. Next, taking the element k vector into column and row are eliminated, getting the minor matrix. This one 1 4s are 4. 4 minus 2 2s are 4. 4 minus 4. That's equal minus 10 plus 2. Sorry, minus 10 plus 12. 12 minus 10 is 2. 2 I vector. 2 I vector. Next one 6 minus 5. 6 minus 5 plus 1. Minus into plus minus 1 into j vector is j vector. Next one 4 minus 4. 4 minus 4 is 0. 0 and anything value is 0. Getting a B cross D is 2i vector minus j vector. Now find modulus of B cross D. That is a magnitude. Modulus of B vector cross D vector equal to modulus of B vector cross D vector equal to, that is the square root of square the values. 2 square is 4. Minus 1 square is plus 1. That is root 4 plus 1 equal to root 5. Modulus of B cross D value root 5. The next one find C vector minus A vector dot B vector cross D vector. That is a dot product of two vectors. Dot product of two vectors. C vector minus A vector dot B vector cross D vector. B vector cross D vector equal to C dot A. C vector dot A vector. Sorry, C vector minus A vector dot B cross D. That is, this one is C minus A. This one is B cross D. Now dot product of two vectors. Minus 3 into 2. Minus 3 into 2. Minus 6. Minus 6. Next one plus 1 into minus 1. Minus into plus minus 1. Minus 1. That is equal to minus 7. So find modulus. Modulus means modulus value is always positive value. Now find the distance between the skew lines. That is the distance D equal to, already write the formula, modulus of C vector minus A vector dot B vector cross D vector by modulus of B vector cross D vector. That is a distance D equal to C vector minus A vector dot B cross D value minus 7. Taking the modulus is modulus of minus 7 by B modulus of B vector cross D vector is root 5. It's a root 5. That is equal, therefore the distance D equal to 7 by root 5. Therefore the shortest distance between the skew lines d equal to 7 by root 5 units. Next problem. Fifth one, show that the straight lines x plus 1 equal to 2y equal minus 12z and x equal to y plus 2 equal 6z minus 6 are skew, and hence find the shortest distance between them. First one, given two lines, so that the result is given the two lines are skew lines. And next one, find given the two straight lines are skew lines. The next one, find the shortest distance between the skew lines. First one, you write in a first equation is x plus 1 equal to 2y equal to minus 12z. This is a x plus 1 equal to 2y equal to minus 12z is a Cartesian form. This is a plain equation. Now write in a Cartesian form. This equation is divided by 12. Both sides is divided by 12. This x plus 1 by 12 equal 2y by 12 equal minus 12z by 12. Now cancel the value 2, 12, the 6 times, 2 6 are 12. Next one, 12, 12 cancel. This implies getting a Cartesian form is x plus 1 by 12 equal y by 6 equal to z by minus 1. Z by minus 1, getting a equation of a straight line in Cartesian form, first equation. And the second equation is x plus 1 equal 2y equal to, x equal y plus 2 equal 6z minus 6. 6z minus 6. Again, write in here same. X equal y plus 2 equal 6z minus 6. Taking 6 is common outside. Z minus 1. Z minus 1. This is a equation of a plane. Now change in a Cartesian form. This equation is divided by 6. Is divided by 6. X by 6 equal y plus 2 by 6 equal 6 into z minus 1 by 6. Now cancel the value, 6 are cancel. That is getting a Cartesian equation is x by 6 equal y plus 2 by 6 equal to z minus 1 by 1. That is the second Cartesian. Now find, so that the lines are skew lines. Now comparing the parallel direction, that is B1, B2, B3, D1, D2, D3. Comparing the B and D. Comparing B and D is, here B is 12, 6, minus 1. D is 6, 6, 1. So B is not a scalar multiple of D. 12, 6, minus 1, 6, 6, 1 are not equal. So B vector is not a scalar multiple of D. Therefore, given that two lines are not parallel. Not parallel means given the two straight lines are skew lines. Clearly, write in here B vector equal to, that is B vector equal 12 I vector plus 6 j vector minus k vector, and D vector equal to, here D vector is 6 I vector plus 6 j vector plus k vector. And the point A and B is here, the point A is A vector equal to, the point A vector equal, that is the formula is x minus x1, y minus y1, z minus z1, that is a point. The point A is x minus x1, that is the formula is minus, that is a plus 1 is, here the point is minus I vector, minus 1. Minus I vector only, that is the y minus y1 value 0, z1 value 0, that is A vector equal to I vector only. The next one, B vector equal to, writing B vector equal, A, B, C, D, that is A, this point is C, C vector equal to, C vector is, that is the point is C, this one x minus x1 here, x1 is not, that is the value is 0, 0 I vector, x1 y minus y1, this minus 2j vector, minus 2j vector, next one plus k vector, that is the point is C. Here A and C are points, B and D are parallels. Now comparing B and D, where B is not a scalar multiple of B, that clearly B vector is not a scalar multiple of D vector. So therefore the two lines are not parallel. Not parallel means therefore the two lines are skew lines. Two lines are skew line. Now find the shortest distance between the skew line. That is a distance D equal to modulus of C vector minus A vector dot B vector cross D vector by modulus of B vector cross D vector. That is a distance between the skew lines. First one, find C vector minus A vector. C vector minus A vector equal to C vector minus A vector. C minus A. First one 0, 0 I vector. 0 minus of minus plus, that is I vector. Next one minus 2j, this value is 0. This is minus 2j vector. Next one k minus 0, that is k vector only. The C vector minus A vector equal to I vector minus 2j vector plus k vector. Next now find B vector cross D vector. B vector cross D vector. Now find B vector cross D vector equal to, now using determinant form, I vector, j vector and k vector. And first write in a component of B is component of B. This one component of B 12, 6 minus 1. 12, 6 minus 1. Next one D is 6, 6, 1. 6, 6, 1. 6, 6, 1. Now expanding the determinant, I vector into 6 ones are 6. Next one 6 into minus 1 minus 6, formula is minus, minus or minus plus 6. Minus j vector into column and row are eliminated, getting the minor 12 into 1 12. Next one 6 into minus 1 minus 6, formula is minus or minus plus 6. Next one take the element k plus k vector into 12 6 72 minus 36 write in 6 plus 6 12, that is 12 I vector minus 12 plus 6 18 minus 18 j vector. Next one 72 minus 36, 72 minus 36, 12 minus 6 6, remaining 6 minus 3 36. This is 36 plus 36 plus 36. That is a B vector cross D vector. That is B vector cross D vector equal to B vector cross D vector equal to 12 I vector minus 18 j vector plus 36 is B vector cross D vector. Now find modulus of B vector cross D vector. Modulus of B vector cross D vector equal to, now taking 6 is common. 6 into 2 times of 2I vector minus 3j vector plus 6k vector, 36k vector plus 6k vector. Now writing the modulus means square root of square value, that is square root of 36 is 6, root of 2 square is 4 plus 3 square is 9 plus 6 square is 36. That is equal to 6 into root of 36 plus 4, 40. 49. Root of 49. Root of 49 is 7. 7 6 are 42. 7 6 are 42. That is modulus of B vector cross D vector value. Modulus of B vector cross D vector equal to 42. Now find the shortest distance between the skew lines. Now it's already find the points. The first one, C minus A is I vector minus 2j vector plus k vector, and B cross D is 12i vector minus 18j vector plus 36k vector. Now dot product of two vectors. Next one, dot product of two vectors divide by modulus of B cross D. Now substitute the distance formula. First one, find C vector minus A vector. C vector minus A vector dot B vector cross D vector equal to C minus A is I vector minus 2j vector plus k vector dot B vector cross D vector is 12i vector minus 18j vector plus 36k vector. Now dot product of two vectors. 12 into 1, 12. 12 into 1, 12. Next one, minus into minus plus. 18 into 2, 36. Next one, 36. 36 into 1 plus 36. 36. 36 plus 36, 72, 74, 84. 84. Please. C vector minus A vector dot B vector cross D vector value 84. That is a modulus value or same value. Modulus 84 is 84 value. Now find the distance. Already you know the distance formula. Modulus of C vector minus A vector dot B vector cross D vector by modulus of B vector cross D vector. Now substitute the value. C vector minus A vector dot B vector cross D vector value 84. Modulus of 84 value 84 by modulus of B vector cross D vector already find. Modulus of B cross D is 42. 42. Now cancel the value. 142, 42. 2 42s are 84. That is a distance equal to 2 units. Therefore the shortest distance between the skew line D equal to 2 units. And next problem. 6.1. Find the parametric form of vector equation of the straight line passing through the point minus 1, 2, 1 and parallel to the straight line R vector equal to 2i vector plus 3j vector minus k vector plus t of I vector minus 2j vector plus k vector, and hence find the shortest distance between the lines. First now find the parametric form of vector equation. So the vector equation of the line passing through one point, already one point is given, minus 1, 2, 1, that is the one point is given, and parallel to the straight line, that is a parallel means, parallel is this one, R vector equal to A vector plus T of D vector or P vector, anyone, that is a parallel. Now I am taking one point and one parallel, that is a point and a parallel. Given one point and one parallel, vector equation or parametric form of vector equation is R vector equal to A vector plus S of B vector. S of B vector is a parametric form of vector equation. The next one, two lines are parallel. Next one, find the shortest distance between the parallel lines. First now writing a point, given the point is, now taking a point is A vector equal to, writing a vector. A vector equal to minus I vector plus 2j vector plus k vector. That is a point. The straight line passing through point and parallel to the straight line. That is a parallel is this one. This one is parallel. write in a B vector. That is B vector equal to, B vector is I vector minus 2j vector plus k vector is a B vector. That is a B vector. That is given one point and one parallel. One point, one parallel. Parametric form of vector equation. Parametric form. Parametric form of vector equation. R vector equal to A vector plus S B vector. That is a parametric form of vector equation. Now writing vector form R vector equal to, now substituting A vector is minus I vector plus 2j vector plus k vector plus S of B vector. Here B vector is I vector minus 2j vector plus k vector. This is equation number 1. R vector equal to minus I plus 2j plus k plus S of I vector minus 2j plus k vector. That is a parametric form of vector equation. And given the second line is, R vector equal to 2i plus 3j minus k plus T of I vector minus 2j plus k vector. Given the two lines are parallel. That is I vector minus 2j plus k, this one B vector. This is a same, that is a B vector. So, two vectors are parallel, therefore, two lines are parallel. That is the second equation of the line is R vector equal to 2i vector plus 3j vector minus k vector plus T of I vector minus 2j vector plus k vector. That is the equation number 2. Therefore, the equation 1 and 2 are parallel. So, first one, the line is R vector equal to A vector plus S of B vector. Now, writing the point is A, that is A vector. A vector equal minus I vector plus 2j vector plus k vector. Equation 1, A vector is minus I plus 2j plus k vector. And equation number 2, the second line is, the point is C vector. This C vector equal, this point is C vector. C vector equal to 2i vector plus 3j vector minus k vector. And C. And next one, B vector is the direction are parallel. B vector equal to, two vectors are same. First and the second are same. One I vector, that is I vector minus 2j vector and plus k vector. I vector minus 2j vector plus k vector. Therefore, two vectors are parallel. Two lines are parallel. That is a P vector. Now find the distance between the parallel lines. Now find the distance between the parallel lines. Already you know distance between the parallel lines, D equal to modulus of C vector minus A vector cross B vector by modulus of B vector. C vector minus A vector cross B vector by modulus of B vector. First now find C vector minus A vector. C vector minus A vector equal to C minus A. 2 minus half minus plus 2 plus 1 3i vector. 3 minus 2 j vector. Next minus 1 minus 2k vector is C minus A. The next one B vector, already know B vector is I vector minus 2j plus k vector. Now vector product of two vectors C minus A, C vector minus A vector cross B vector. First now find C vector minus A vector cross B vector is vector product of two vectors. Now write in a determinant form I vector, J vector and K vector. The component of C minus A is 3, 1, minus 2. 3, 1, minus 2. The component of B is 1, minus 2, 1. Now expanding the determinant. That is implies I vector into getting the minor material. 1 ones are 1. Next one formula is minus 2 into minus 2 plus 4. Formula is minus is minus 4. x1 minus j vector into column and row element getting the minor matrix. 3 ones are 3. 3 formula is minus 1 into minus 2 minus 2. Formula is minus plus 2. Plus k vector into column and row are eliminated getting the minor matrix. 3 minus 2 minus 6. x1 1 into 1 is 1 minus 1. 1 into 1 is 1 minus 1. Which implies 1 minus 4. 1 minus 4 is minus 3. Minus 3 I vector. 3 plus 2 5 plus minus 5 j vector. Minus into plus minus 5 j vector. x1 minus 6 minus 1 minus 7 k vector is c vector minus a vector cross b vector value minus 3 a vector minus 5 j vector minus 7 k vector. Next now find determinant modulus of modulus means modulus of c vector minus a vector cross d vector equal to, this is square root of value. Square root is 3 square minus 3 square is 9 plus 9 plus 5 square is 25 plus 7 square minus 7 square is plus 49 equal to root of 25 plus 9 34 25 9 34 plus 49 9 plus 4 13 remaining 1 4 83. Modulus of c vector minus a vector plus d vector equal to root of 83. Next now find modulus of b vector. Modulus of b vector, modulus means square root of square the value. Already b vector is I vector minus 2j plus k vector. I 1 square is 1 plus minus 2 square is 4. 1 square is 1 root of 4 plus 1 5 plus 1 6. Modulus of b vector equal to minus 6. Now find the distance. The distance between the parallel lines D equal to modulus of c vector minus a vector cross b vector by modulus of b vector. Now find the distance. Now substitute in the value. Modulus of c minus a cross b vector value root of 83 by modulus of b vector value root 6. Therefore the distance is D equal to root 83 by root 6 units. That is the shortest distance between the parallel lines D equal to root 83 by root 6.